Hi guys, hope you're all doing well. It's Mr. Brown here. Today I'm going to do a screencastify where I take you through the new topic of geometric probability. So you might remember probability from last week. It's the number of successes divided by the number of trials. It's going to be similar here. The number of successes is going to be the shaded region or the region you're looking for, and then the total is either going to be the total region of the shape or it's going to be the total amount on the number line. What I'm going to do here is just take you through each of these 7 problems. I'm going to do them all out. You can copy my work if you want, and as long as you complete these 7 problems, you are good for the day. So problem 1, find the geometric probability of a marble falling on the shaded region of the figure. So to start, we're going to count the number of figures. 1, 2, 3, 4, 5, 6, 7, 8. And all of these 8 shapes are exactly the same area. So the quick way of getting the answer to this question, the top part is going to be the total number of shaded regions, which is 4. And the denominator is going to be the total area, or in this case, the number of equal regions, which is 8, making our answer to question 1, 50%, 4/8. Okay, moving on to problem 2. Let's see if I can delete this. So it's going to be a similar problem as the last one. So a stone is dropped at random on the tiles. What is the probability of the stone landing on the black tile? So if you look at each of these tiles, they're all squares and they're all the same area. So the first thing to do is count the number of little squares on this figure. So count them. I got 9 total squares. So our denominator is going to be 9. Now you want to count the number of black tiles, which is 1, 2, 3, 4, 5. So the number of successes would be 5. The number of trials would be 9, making our answer A, 5/9. Okay, moving on to the next one. So this is a number line problem. Find the probability that point K selected on AE is on AC. Express your answer as a fraction. So the first thing to do is find these different points. We have A here, C over here, and E over here. So first, the total length from A to E is going to be the denominator. So if you start at 8, 0, and go to E, 8, that means it is 8 units long from A to E. So what we're going to do now is find out how long it is from A to E. A to E, or A to C, excuse me, for AC there. AC goes from here to here. So that looks like it goes from 0 to 4. 0 to 4 is 4 long, a total of 8 altogether. That makes our answer to this 4, the length of AC, which is 4, divided by 8, which is the total length from A to E. So we're going from A to E, and we're finding just this part of it from A to C, which is 4/8 of the way. Either one of these two answers would be fine. The answer key probably has A as the answer, 1/2, the reduced version of 4/8, but I would accept either A or C as correct answers to that problem. All right, let's go on to problem 4 now. All right, so problem 4. The probability that a point K is on AE is on BC. So we go from A to E here. That is once again a denominator of 8. BC this time, right? Because we're looking for what they're asking for in the problem, which is BC, right there. So B is here, C is here. If you go from B to C, that is 1, 2, 3 units long. To go from 1 to 4, it takes 3 units. So that means our numerator is going to be 3. Our denominator is going to be the full length of 8, making our correct answer D, 3/8. Moving on to problem 5, the probability of landing on a blue number. So if you look at these 8 digits here, each one of them has an equal area. Since they all have an equal area, we can divide the total number of blues divided by the total number of spaces. There are 4 blues divided by 8 spaces. That would be 4/8, which reduces to 1/2 again, because if you divide 4/8 by 4, you get 1/2. Moving on to number 6. If you throw a dart at the square design below, what is the probability you hit the middle region? So for this, you have to actually find the areas. So this area here is going to be 36. And I get that by doing 6 times 6. So that means my small region here, the one on the inside, is 36. Now the outside is also going to be a square, 8 by 8. 8 times 8 is 64. So that makes the whole region 64. If you look at the answer choices, they're all decimals. So if you take out your calculator, and on the calculator do 36 divided by 64, you get 0.5625, which is answer C. So to do these geometry problems, you find the inside area, 36, this part here, oopsie, and that's your numerator. And you divide that by the total area of the entire figure, which in this case is 64. Okay, I'm going to erase this and move on to the next problem. Okay, moving on to the last one, number 7. If you pick up one at random inside the large square, find the probability that is in the small square. So the large square in this is the blue one. So the blue square, find the probability it is in the small square. We need to find both areas, the area of the small square and the area of the large square around it, and we're going to divide those. The area of the small square is 1 times 1. The area of the large square is 2 times 2. 1 times 1 is 1. 2 times 2 is 4. That makes our answer 1, the inside part divided by the total area of 4. And our answer is B, 1/4. Alrighty, guys, send me an email if you have any questions on this. But this is just day 1. We'll continue this through the week. Please scan and submit them into Schoology, or if you did them on a separate piece of paper, just kind of put your work and your answers and submit them through Schoology that way. Thank you.